Okay, hey everybody. So this is a video on 3A, and mostly I just want to repeat some things that I said in lecture. But the thing I think that I'll do that's beyond lecture is I want to try to connect the project to the lecture a little bit better. So let's start with the lecture. As I'm sure remember, we wanted to show an example of an abstract data type, and it was an abstract data type that could do store and fetch. And so let me write that down. So our class example was an ADT, abstract data type, and I think what we said is that in Python something that can store and fetch is a dictionary. So let's refer to this as a dictionary, and it's got two methods, store and fetch. And the way it's positioned in the slides, it actually is just kind of called, I think, a store fetch. But there is a concept behind this in Python, which is dictionary. So let's use the word dictionary. And here are two methods that we have. And what we wanted is we wanted to have for our, and this is the example we did in class, is for our ADT dictionary. And again, the slides don't say dictionary, but I'm gonna use the word dictionary. We had two implementations, and so one implementation was a dictionary. Dictionary with hash tables, and the other was a dictionary with arrays. And we implemented both of these. We showed, and then we had these two functions, store and fetch. And so for this one, dictionary plus hash tables, we had to have a store, a hash table store. So for a dictionary that uses hash tables, how do you store? And we had to have a fetch. And similarly for arrays, for when we're doing a dictionary with arrays, we had to know, again, how to store and how to fetch. Because these are the functions that our ADT exposes. And so we took this concept of hash tables with store and fetch and arrays with store and fetch, and we packaged them up into a dictionary. And so I'm going to go right to the end. Here's the stuff with, let's see, here's the stuff where we had our functions for arrays, and then we did it for hash tables, and we learned about hash tables as we went, and then here's where we did it for hash tables. And so then we said, okay, now we have these two things, array and hash table, and now we're ready to do an ADT, and we had to have this concept of a dispatch table. And so one of the things that we saw is when we did our ADT, that our ADT didn't have any state. So when I say state, for a hash table, we had to have a place, an array to hash things into. For our array, we had to have an array to store things in. And the ADT doesn't have any of that. It just has this void pointer where the data goes, that we're calling self. And then it defines an interface of store and fetch. And so for this interface, it's done with a pointer to a function, and it takes this void star, which is a chance for us to send in the data, right, this self data, and then it takes the regular interface for store, which is int and student, and the regular interface for fetch, which is an int, and it returns a pointer to a student. And so this is the standard interface for store and fetch with a void star passed in so that we could do our data. And so this is our dispatch table. And so one of the ideas here is that when we're in the main function and we're a user of the ADT, well, we don't want to be worried about the dispatch table. And so we're going to call these functions ADT store and ADT fetch, which will set up using the dispatch table for us. And so here's our, and so now this is something else, which is we have functions that use the dispatch table to invoke the proper functions for the implementation. And for the implementation, what I mean is, like, if you are using ADT plus a dictionary plus hash tables, and you want to call store, then we need help to call hash table store. And hash table store was a function that we defined when we defined our hash table. Here was hash table store, and by the way, it took in a void star, which was a chance to send in the data associated with the hash table. So here's the data associated with the hash table. And when we called hash table store, we sent in that data and we did a cast. And this was the moment that we said, okay, you're sending us this data, it's void star, but we know that this is a hash table, and so we're going to cast this data to a hash table. And by doing that, now we've got a pointer to a hash table, and we can go and access the data members, the keys and the values, through this pointer. So it's through the store that we get access to this stuff. And so we had a function that uses the dispatch table to invoke the proper implementations. And when we go look at this, it's down here. And so for us, it was called ADT store and ADT fetch. And so ADT store is getting us from the moment that we're in the main function and we say, hey, we know we have an ADT, we know we want to do a store, here's the pointer to the ADT, here's the stuff I want to store. How do I use the dispatch table? You know, I'm a customer, I don't want to figure that out. And so that's the value add of this function, is that it goes through the effort of saying, okay, here's the entry in the dispatch table that has a pointer to the right function to call. And in the case of, for example, I said direction, sorry, of a dictionary plus a hash table, then I want to call hash table store. And so it calls that function. Now by the way, the reason it knows to call that function, let's see, I think that's what's in red here, is when we do our initialize function and we set up the dispatch table, we actually called right here, we set the pointer to the function to be the right appropriate store function for this flavor of dictionary, the flavor of dictionary that has a hash table. Okay, so what we've got here is we've got, you know, in main, you know, it's I am using an ADT. I don't want to know the details of dispatch tables, etc. So I call this function that does the dispatch table work for me, which is like ADT store or ADT fetch. And then ADT store and fetch use the dispatch table to, and specifically use the function pointers in the dispatch table to get to the right implementation of store or fetch. And like, so for example, with hash tables, we wanted hash table store. Okay, so that's what how I would summarize the slides. And then what I would say is in the homework 3A, you know, now we're not doing a dictionary, and in fact, a dictionary is a data structure. This is just a type. It's a fruit. But in the same way that our dictionary had methods, our fruit has two methods: get color and get volume. And I'm just going to copy this stuff up here. And so now for our fruit, well, you know, before it was an abstract data type, and we said, oh, it's a dictionary being implemented with hash tables or a dictionary being implemented with arrays. I don't really want to say a fruit being implemented with bananas or a fruit being implemented with apples, because this is kind of more an abstract type than an abstract data type. But what we have is we have an apple and we have a banana. And each of these have methods, which are like get color and get volume. And in fact, they're not called get color and get volume. I think, and if you look at the code here, it's called like banana get color and banana get volume. And the reason why it can't be called get color is you can't have a function called get color here for bananas and the same function name for apples, because the compiler will get confused. So you have to give them unique names. And then there was this issue, which is in the main function, we knew we were using an ADT, and so now I'm going to say, well, in the main function, I am dealing with a fruit, right? And again, I'm just going to copy all these lines of code. I don't want to know the detail of dispatch tables. That's the same. And so here you can see, instead of calling ADT store and ADT fetch, I want to call fruit get color and fruit get volume. And then these functions, whoops, and fruit get volume use the function pointers in the dispatch table to get the right implementation of like banana get color of get color or get volume. And in the case of bananas and get color, we'd want to call banana get color. And so if we look up here, this is being done for us. We don't have a dispatch table defined. We don't have an apple or a banana or fruit defined. But you see in my code that I said you shouldn't modify, I'm saying when I create a banana, this is my initialize function, that when the dispatch, in the dispatch table, the function pointer to get color should call banana get color. Now banana get color hasn't been defined, but really banana get color, and you can see these notes are intended to line up. Hash table store and banana get color are very similar, occupy very similar roles in this, between the slides and Project 3A. I think that's most of what I wanted to say. In this explanation, I didn't emphasize the initializers, but here are some initializers: create apple, and here's another one for create array store fetch ADT. And so these are initializers that return an ADT, but also set up, a hash table or set up an array. By the way, and I pointed this out in class, this is really embarrassing. This slide needs to be corrected because it's actually not allocating enough memory. This needs to allocate memory. This should say the hash table, and because that's what it's trying to malloc. And so it's actually, this is the correct size for this type, but this is the incorrect size for that type. So, whoops, and I'll get that fixed. So the other thing is, I've been emphasizing all term. Don't write 100 lines of code and then try to compile it, and then it doesn't work, and you have to spend a long time tracking stuff down. Especially if you look at the number of asterisks involved, it's really hard to get it all right the first time. So my advice would be to build the abstract data type, which is a fruit, and it's dispatch table, and compile that. And only add one function, like maybe just focus on get color or get volume. And if you focus on get color, just comment out this line, and comment out these lines somehow, and compile it, and then add just one type, like just an apple, and apple get color, and then get that to work and get the entire machinery to work. And when you have that all working, then add volume. And then once you have color and volume going for apples, then add bananas. But I really encourage you to find ways to break this up and to not try to write everything at once. Okay, I hope this is helpful for you all in terms of correlating the slides and the example in 3A to the example in to what I want you to do for I don't know. That was terrible. I'm still going to keep the video. This video went well up until that moment. I hope this was helpful for correlating the slides with 3A. That's what I wanted to say. Okay, good luck, everyone.